All right, just a few minutes late on to the next one. The next one, we actually combined two blueprints into one, talking about faster peering and improving tail latency, relatively related or almost the same thing, I guess. Sam, Guang, you guys wants to go first? Looks like Sam gets to go first because I don't see him on the list. Oh, there he is. Okay. Sam, you want to start it off, and then
1 sec.
he can pick up the tail latency stuff.
Sorry, my laptop restarted itself for some reason.
Oh, awesome. Well, Sam is waiting
Okay,
on that.
here we go.
Okay.
Okay.
Fire away.
So, in the blueprint, I put in the peering state chart just so we get a feel for which steps are necessary. But there are three particular steps that are the sort of main contributors to round-trip latency in peering. And that's that when peering first starts, the first thing we do is we compile ourselves a list of everyone we could conceivably need to talk to. And then we ask them for a PG. We ask them to send us a PG notify. Let's see.
Or PG info query or whatever. Yeah.
Well, they send back a PG notify message. We wait for all of them before we proceed, if I recall correctly. We don't send these queries, of course, to down OSDs. So that means that if an OSD is not going to send us a notify because it's dead, this is going to stall until that OSD gets marked as down and we stop waiting for it. It affects the prior set and causes us to restart peering. So we'll assume from here forward that the OSDs don't die. So this is it's not part of the process. So first we wait for everyone to send us notifies. Then we use those notifies. Those notifies contain the PG info for each OSD, and we use that to make a decision about which OSD has the authoritative PG info, the one we are going to go forward with. We then ask that OSD for its info and log, because we are going to use that to adjust our own log and missing set, and then to adjust everyone else's missing sets once we get their logs. So once we have that, we adjust our own log and then ask everyone in the acting set and everyone we could conceivably need to pull an object from for their log and missing set, so that we know which objects they actually have on disk. And for our own acting set, we know which objects we need to recover over to them. That's log-based recovery for those of you following along at home. Let's see. After that, we finally send out an info message to each of every OSD we're going to activate, which is the acting set and anyone we're going to need to recover objects from. And that causes them to adjust their logs to the authoritative log. Once they persist that, they can go active. So if we're keeping track, that's 3 round trips. And at the beginning, we have to flush all of the IOs from the previous interval before we can send anything to the primary or before the primary can send anything to anyone else. And then at the end, before we can accept writes, we have to persist the update to our own info and log, lest we tell the client something we're not allowed to. So that's 2 distinct flushes and 3 round trips. So the question is, how much of that is necessary and can we make it faster? The 2 things I had that seemed like they might work is, based on the past intervals, there's a decent chance that we already know who's going to have the authoritative log. For example, we might know that it's almost definitely probably going to be us or the primary from the previous interval. So when we send out the first round of requests, if we're in a situation where we can heuristically feel like we have a good shot at being right, we can also ask for the login info, or for the login missing set from that OSD. That saves us the get log step if we happen to be right. And we can check this. Once we get back all of the notifies, we can verify that we asked for the correct one. And if it happens that we have it, then yay. Similarly, for the get missing, we already know which OSDs we're going to need missing sets and logs from. That would be, well, we know the first batch. We know everyone we need to go active. We only actually need the missing and logs from the acting set. We don't actually need them from the people we're going to recover from. We can do that part subsequently. Well, we can ask for the logs and missing in the get info step as well. So in the best case, we might be able to get this down to 1 flush and do 1 flush and 1 round trip and then 1 additional commit. A related piece is that we currently need to flush the stuff from the previous interval, where ideally we would actually like to only commit it. That is, only make sure that it's in the journal. The reason we need to flush it is because when we go ahead later and serve reads, we don't know which objects are dirty, or we don't know which objects have pending IOs. So if we track object contexts across intervals, that is, we remember from the previous interval which objects had in-flight IOs, we have an in-memory structure for this we keep around while we're the primary. So if we extend that to keep that structure around when we're the replica as well, even if we're not active, until all of the IOs finish flushing, then we would not have to wait for it to apply only until it commits, which might save us a little bit more time.
Okay. Okay. So I have a couple of questions. I guess the first would be, it seems like in many cases there actually wasn't anybody going down up and down, but we have a forced interval change anyway, like because the PG temp record was set, for example, but it actually set it to what we were before. In that case, like everything we already know is still correct, and in fact we already have the peers. Like a lot of times we already have the peers info. We don't need to request it because we know they didn't go down or come back up again.
That's a good point.
That's maybe this is even
difficult.
just a general case where we're like, I'm not going to bother requesting this peers info because I know in the previous interval and this interval they're still up.
Well, it's more like when we go through start peering interval, maybe start peering interval, we observe that the acting set didn't change, and that therefore we should not flush our missing info and log sets and go through a truncated peering process, because all of our information is still authoritative.
Or even if one OSD went down.
Well, yeah, right. Okay, so that's
then
true.
The other two.
But I mean, even
didn't go down, and we just, yeah.
So, and we can generalize it even more. That's true.
Yeah.
So that's actually a good point. I hadn't thought about that.
Because then it could just basically say you have 3, one of them went down. It could just basically send an info that activates them immediately, like without even doing any further work, because we just went from 3 replicas to 2. Yeah. Okay.
I mean, I think we actually have all the information we need to do it in the start peering interval. And so the only difference is we don't reset. We set a different event that sends us through a truncated circuit.
Okay.
Because the catch is during new peering interval or whatever, we clear blank state for absolutely everything, just to make sure we don't contaminate the next interval because of all the bugs we've had from that.
Yeah.
So it just means relaxing that part for the truncated peering case.
Yeah. I mean, it might make sense to sort of call out the specific cases that we care about. Like it's when we have a PG temp that's the same as our current set anyway, or when an OSD goes down and we just want to like keep going.
Actually, I'm not sure that a PG temp that's the same as our current set actually causes a peering interval change.
It has to, because actually you might be right.
Because it doesn't change the upper acting set.
Yeah,
in fact, we would never set that PG temp in the first place.
Yeah, well, what I'm thinking is if we dispatch that's pending, if on a proposed crush map, we pre-populate all the PG temps.
Oh, yeah.
But that's actually, we want to make sure that doesn't cause trigger peering.
Yes, that's true.
Yeah.
Even so, though, if basically by definition, by construction and the way we maintain all of the PG temps, we never have a PG temp that's the same as Crush's acting set output.
Right, actually. So in that case, actually, it does force a pending, because the thing that changes is the upset changes, but the acting set stays exactly the same. So by definition, it's a new interval.
That would cause a peering change, yeah.
But we want that to be.
If the acting set didn't change, and that's annoying, because we actually have to ask those 2 OSDs before we actually have to go through get info in that case. That's not optional.
Do we? If we were already active, and we already know that the people who are in the previous interval obviously are up to date?
Yes, I think so. Basically, we would have to remember that. We would have to know that the previous interval actually went acting. I guess if we know that the previous interval went acting because we can look at our state and we're the primary when acting, then we know that our own info has to be authoritative.
Yep.
The problem is that we don't know how much recovery we have to do on the other guys. So we actually do still have to ask them before we can go active.
Okay. Unless we push all this, like, yeah, like getting all that stuff to happen after they go active, which would greatly
Well, I mean,
complicate
you
things.
could preemptively just you could send them a message that says, "I really couldn't care less what your state is. You're now backfilling." I mean, that's the only way to do it, though.
Yeah. I mean, if we could just assume that because we know that they were actually up in the previous interval also. And so most likely if they did have any data, they would have sent us a notify, and we know that they're not stray. And so
Oh, that's
we
a
could
good
make that
point.
assumption.
Yes. All right. All right. Yep.
It's
Agreed.
it could have just been really slow to arrive, so we're not totally certain, but that's
Yeah, but clearly we
highly
didn't need
likely.
them if
Yeah.
we're active clean.
Yeah, exactly. Yeah, yeah.
You're
Okay.
right. That's a good point. Right.
Or,
And so another piece to this is when the monitor sees an OSD come in, it oh, sorry. Was there anything else you want to talk about truncating pairing? I was going to move on to the other two, which I forgot to add to the blueprint, apparently.
yeah, I don't see any. Yeah, go for it. Yeah.
Okay, so the other two pieces are, so previous CDSs, we've already booted the idea of pre-populating the PG temp with sort of what we expect the PG temp to wind up with as soon as the primary finds out that it shouldn't be the primary and requests a new one. We do something like bound the amount of time the monitor spends on it, and then whatever we come up with, that goes into the next map, and hopefully that cuts down on the work. Does anyone want me to go over that more? Because there's that. Okay, cool. One other thing we can do is there is a thing where if you take the primary of the placement group down and bring it right back up, it'll be missing a few writes, but it'll still be primary. And some IO will tend to kind of hang on those objects because we have to recover them before we can serve reads or writes on them. So it's possible that in many such situations, we would prefer that for a brief period of time, the monitor simply set, or when an OSD is marked up after it was down for a brief period of time, we would like the monitor to set its primary affinity to 0. Oh, that's right, because we can't do a per PG primary affinity because it would affect all of the PGs. Annoying.
You could do a
could do a temp primary though.
Oh, actually, that's in the MOSI map. Now that I think about it.
Yeah. So we would set a temp primary, and each PG would then clear it on a case by case basis. So we can do that too. So that combined with the changes that went into Hammer, which allow us to perform writes on degraded objects, will mean that those objects won't see write or read fluctuations.
Okay. So I think that the main missing piece there is that right now in peering, if during peering we decide that the acting set should be different, we just sit there and wait up through, even if the current acting set could go active, right?
Oh, hang on. I forgot about wait up through. Hang on.
Right.
Why do we need up through? That was because.
Well, just in general, we want to switch acting to be what we want it to be. But even if the previous acting is good enough, then we should go active and then asynchronously wait for the up through to get the PG temp to get remapped. So this is actually a problem with the PG temp pre-populating too. This is also going to hit this case.
I'm confused.
Okay, let me see if I can remember. So if you set say you're mapped to 123 and crush changes to be like 312, and so you set up PG temp to be the old thing, and it goes through peering, and it's like, well, I could be 123, like that's good enough. It will sit there and block instead of waiting for yet another OSD map update cycle. Instead of continuing
Why would it ever do that though?
That's a bad example.
It wants to switch the primary?
Or yeah. I mean, it basically, because in peering, it gives you like, this is exactly the best acting that I would want. And if it's not exactly that, then it waits for it to be that.
Pretty much the only cases where, so usually that's because the primary that it currently is mapped to is not complete.
Mm-hmm.
So I can't think of a case actually where the primary would be able to be the primary and would not leave itself as the primary.
Well, I mean, the example is actually the temp primary mapping.
Yeah, so I think that one really only
would
works
example.
if the well, see, I'm not sure it's worth doing if the OSD has to do it. I think the monitor atomically with the map change that marks the OSD up also switches the primary.
But then during peering, it will say, well, I see I'm 213, but I could be 123, and so I should switch to that, and it won't actually do I/O in the sort of its temporary state. Like
No, it would
we're sort of,
immediately, as long as we set this up so that it doesn't immediately try to clear that, which it shouldn't, then it'll just
that's what I'm saying, it
immediately.
does.
Huh? Yeah, well, currently would try to clear it. We would have to have it not do that.
Right.
We don't want it
But
to clear it. We want it to go active
Right.
with this
Right.
until it goes clean.
Right. So that's actually what I'm saying is that that's a totally generic thing. Basically, when we get to the wait up through decision, if we could go active with our current acting set, even though we want it to be something different, we should continue and go active and asynchronously.
Yeah, I know. I just can't think of a case where that would happen in the current code.
I have to think of an example.
I mean, the only case I can think of where that might happen is if someone new in the prior set came up, and for whatever reason that just became the one we wanted to use as the temporary primary. We would actually wait until it switched, but that's quite rare.
Or what if you're degraded with no, but then yeah, never mind.
Yeah, because if the upset primary is capable of being primary, it will be. It's
Right.
not going to try to change the acting set for that.
Yeah, okay. I'm pretty sure I had an example before, but I can't remember it now. So maybe we'll leave this to last.
Yeah.
Okay.
And with the PG temp change, we just we would need to wire in some logic so that it doesn't try to change it back. That's all.
Okay. So
I think even with the truncated peering takes too long to switch the primary if the monitor can't do it itself before anyone actually does any work.
Yeah, exactly. Should we switch to the issues that Guang has here?
Yeah, sorry, I used up too much time. Go ahead.
Hi, Sage. Hi, Sam. Hey, I put a blueprint which is talk about the tail latency issue we came across. Is I think at least some of the issues we came across. One is peering. That is when an OSD is down for a while, it's like it's either crash or the some other stuff and bring it up. The peering during the peering stage, there tail latency. Some requests just take tens of seconds to be served. So I think that is already covered by the PG temp change and the blueprint Sam just talked about. Another.
Sorry, on the ungraceful shutdown, you mean? I mean, I think that.
Yeah, the first one is the peering one, and another one, another one is ungracefully shutdown scenario, as I mentioned in the blueprint. Is like because the down status of the OSD can only be noticed by the cluster by its peers via heartbeat, and that could take up to 20 seconds, and cause a map change so that the client could retry in that regard. So I'm wondering if there's any chance we can make that better.
The OSD does actually do that if you shut it down gracefully. So maybe it's not.
That's the ungraceful case, though. So the crash.
Yeah, no, I know. But so a lot of crash. I guess any crash case which results from I/O, we could absolutely choose to send a message to the monitor. There's no reason why we couldn't.
Right? Yeah. I wonder if a more general thing would be. I mean, basically, if there's any situation where we know for certain that the OSD is down, that has no false positives, then like great, we can immediately mark it. So I mean, the things that might work would be if you are another process on the same host and you know that the OSD was a specific PID and that PID disappears, then that would be a trigger.
Yeah.
I mean, or we could just add a watchdog process.
Yeah, exactly. Right. So maybe the Calamari agent could do it. Maybe peer OSDs on the same process, on the same host, could like monitor each other's PIDs.
Way more complicated than a watchdog process.
Yeah. But the watchdog process needs to somehow know that this particular OSD is in fact this PID in this PID namespace.
Yeah, I think that the it would need to be wired through the upstart or other thing, systemd, so that it actually is the thing that does the starting and is the parent.
Yes. We
Yeah,
talked
that's
about
what
this
we
a long time ago. That's right.
That's the classic way to do it.
Yeah, I forgot about that. Yeah.
Yeah, systemd and classic, yeah, but yeah, systemd would be the way to go.
So there's probably even a simple hook that you can just make a run this command when the daemon shuts down, and it can just do Ceph OSD down.
I forgot about that. Yeah, that's probably true.
Okay. So in fact, I think we talked about this like a year and a half ago and forgot about it. I think that the trick was we need some way to identify a particular instance of the OSD, ideally, at least the particular instance. So
systemd has all that information. So would upstart. Any init system, right?
Kind of.
Because
like
we give it like the ID thing.
I mean, you know it's OSD 12 or whatever, and so you can mark down OSD 12, but you don't know that OSD 12 didn't start up in a different process or something. So maybe if that failure command knows the PID of the PID that failed, then when it sends a command to the monitor, it says mark down this OSD if its PID was X or something. I mean,
the way we invoke the process, it could actually be invoked with a file descriptor in the Ceph, and the OSD could tell its parent process what its nonce is, or all of the information needed to identify the instance. That's the simplest thing, I think.
Maybe it's, I don't know, simplest, but okay. Does that make sense? Like if we can figure out a way, if we can figure out a way with the systemd hook to identify that it's that specific process, so that when we send the OSD down command, it only marks it down if the one that's currently up in the OSD map is that same one, then we're golden.
Well, I think we'd add a Ceph OSD inst down, which takes the additional.
Something like that. Yeah. Whatever that unique thing is. Like it could be the inst, it could be that there's a cookie that we put in the OSD metadata or something, whatever. As long as it's okay.
I mean, there's something we're communicating to all of the OSD's messenger peers, right? The entity inst t, is that it?
Yeah, but systemd doesn't know that, so it can't pass it.
I know, but we could. Basically, systemd could, instead of invoking Ceph OSD, it could invoke Ceph OSD supervisor, which knows how to communicate with its child process. Just this little bit.
Yeah, or the Ceph OSD. Yeah. Okay.
Yeah. Previously, I thought of two options. One is that, like we just discussed, is that out of the OSD process, we have another watchdog process or some other stuff which detect the failure of the OSD and report immediately as soon as the failure is detected. Another one is, as I mentioned in the blueprint, is that the OSD preemptively tell the monitor that it's going to crash. Is similar to the gracefully shutdown stuff. Just send a message before it goes crash. So with the discussion that the first option is preferred, is that correct?
Well, in the crash case, I'd rather the OSD not do anything but just die. If we can gracefully do it some other way, which I think the supervisor accomplishes for us.
Okay.
Anyway.
Yeah. Or systemd.
Because they're right. I mean, just some flavor of supervisor process avoids the thing where it's actually a memory corruption thing, and we segfault it.
Yeah.
Even in that case, it would be able to tell the monitor, which would be nice.
Yeah. Correct. Okay.
Yeah.
The second one is that there's some slow OSDs. Actually, this includes that the OSD goes down for some reason. And currently, we have a patch. I think it's already in the test suite. Is that we read all the trunks, both data and the coded trunks for user coding, and use only the first return K trunks to serve the request. That definitely avoid that if there is OSD that is slow or even is down, that the request can be successful and in low latency. But the problem is that that doesn't work for the scenario that the slow OSD is the primary one. So that
Yeah.
in order to fix that problem, it seems like we need to shift the responsibility from the primary OSD to client side.
Yep, I was going to say the same thing. So we talked about this a little bit earlier, that in order to do EC reads from the client, the thing that's missing is, one, the ability to for the client to explicitly read the different shards from OSDs, which is a minor Liberatos extension, and there's some locking stuff that we have to fix on the OSD so that they actually give you the right information. The other sort of hurdle, though, is that the Liberatos client then needs to be able to link in all the erasure code plugins. And currently doesn't, so we have to change the way that the package, right now they're part of the Ceph package, I guess. We'd have to change it, and we'd have to switch around the way that the package dependencies work, basically, so that it can do that, at least in some cases. If it fails, it can always fall back to reading from the primary. But
yeah, if that's some direction we potentially pursue in the future, or we just keep the current workflow.
So another thing is, if it's the storage that's slow and not the request handling on the primary, then you can still just you can still go ahead and try to reconstruct when you have the first K come in, and you don't have to wait for the one on the primary to finish.
Yeah.
Right.
Yeah, it might be the CPU though, I guess.
Well, if it's the CPU, then it doesn't help. But if it's the storage, it does.
Yeah, definitely. Yeah.
If you move the erasure coding stuff to the client, then that would also mean to integrate it in the kernel client, for example, correct?
Only if you wanted to do this. Only if you wanted to do this optimization, right? This is an optional thing that the client could do, and it's optimistic inherently because there might be a racing right, and so if you get back different versions of the shards, then you just give up and fall back to reading the primary anyway. So it's totally fine for the client not to do it.
Incidentally, for writes at least on replicated pools, it seems to me that the analogous thing would be waiting for min size replies. I don't know what anyone would think about that, because we already have a min size parameter which sort of defines how many writes we require to be persisted before we accept reads and writes. So we actually could possibly wait until you had min size replies on a particular write.
Okay. So you are talking about the second one, is right? So that our previously is only for read, and if we want the same effect for write, we probably already have some machinery in at OSD side that supports it, right?
Well, there's no machinery for that yet, but I'm not sure that it would break Rados. Let me put it that way.
Okay.
Sage is
I think it might work, but I'm a little bit worried that we assume that we touch all replicas because of the way that we do peering. Like if we have at least one person from the previous interval, then we assume that any unact write, any write that we didn't see is an act.
Yeah.
Right?
Yeah, you're right. It doesn't work. You'd have to do the same thing we do with the erasure coded pools, which is make sure you talk to at least size minus min size plus 1 replicas.
Yeah.
Yep. Okay.
Yeah. Okay.
I knew there was something I was forgetting.
Yeah. Almost.
Well, we could do that though. You could make it so that you always have to talk to size minus min size plus 1 replicas during peering. But it would increase the chance of unavailability.
Size minus min size plus 1.
Yeah, I think that's right.
In the replicas, in the 3x with min size of 2, that's still 2.
Yeah. Right.
Okay. So during peering, you have to talk to. I see. During peering, you have to talk to at least 2.
Right.
Got it. Yeah, that does increase your risk.
It does.
Yeah. Okay. That is pretty much what I have for this general one. So I will go ahead with more information for the first stuff that is ungracefully shut down.
Okay.
Okay. Thank you, Sage. Thanks, Sam.
Yep. So I think, just to throw this out there for the slow OSDs for the EC thing. I think the thing that's going to best solve the problem for the EC case is going to be the client-driven reads. I think that's probably where, if in latency-sensitive environments, I think that's the way to go, because you don't care about tracing writes and so forth. So
yeah, okay.
Unless Sam disagrees, I don't know if he likes this
Oh,
idea
you're
or
right.
not.
It saves you a round trip or a network hop. There's really no arguing with it.
Yeah. Okay.
Awesome.
It does,
Does that
however,
wrap
mean
that
that
up?
all of the it means that all of the plug-in decoding stuff has to be on the client side.
Yeah. I think it's more of a packaging challenge, but it's optional. It's optional. So if we don't find the plugin, we can just fail. So whatever.
Yep.
Yeah.
Okay. Cool.
Cool. Thanks.
All right, we'll wrap that one up.